Now we will look into asymptotes which are not parallel to any coordinate axis. So solving them are a little bit tricky. For that, I will first tell you or give you here a working formula how to solve them, and after that we will apply this formula and solve some of the problems. Okay. First you will be given a curve. So you will be given f of xy is equals to 0. Then what you have to do, you have to find asymptote. That asymptote will be look like, since it is not parallel to coordinate axis, it will be look like y equals to mx plus c. For better understanding, I am giving you, I am writing here a particular f of xy. For example, x y square minus x cube minus y square is equals to 0. This is our fxy. So what are the working rules? So first, number one, what you have to do, whenever you have given a f of xy, for example like this, first look for nth degree terms of the curve. Okay, so who are the nth degree term of the curve? Nth degree is the highest degree. Here for this particular curve, what is the highest degree? Highest degree is 3. This portion becomes the third degree terms of the curve. Okay, now second, you have to put x equals to 1, y equals to m. Where? In the nth degree terms and name it phi n m. Okay. Then obtain, what you will obtain? Phi n m, phi n minus 1 m. Also find out the derivative for phi n m. Okay, let me say, what is phi n m? Phi n m is the nth degree term of the curve. We already looked who are the nth degree term of the curve. For this particular curve, the nth degree term are x y square minus x cube. For 2, we can write using 2 that here, since it is degree 3, so phi 3 m will be, by putting x equals to 1, y equals to m, we will have m square minus 1. This is our phi 3m. Phi 2m, what will be our phi 2m? Phi 2m will come from that minus y square. Okay, so after getting this, number 3, for m, form, not form, for m, solve phi 3m is equals to 0. This will give values for m. Say m is equals to m1, m2, mn. Do you recognize what is happening overall here? See, we are finding y equals to mx plus c, this straight line. For that, we need to calculate m and c. The working rule is going in that direction. We will find m. See, we have already figured out who are the m's, and for each m we will figure out now c. So if you have n many m's, then you will have n many c. If we get n many m and n many c, then using them we will have n many asymptotes. Yeah, that's what we wanted. Okay, so the number 4, since we have already figured out who are the m's, now the one more thing, we have n many m's. Some of them will be repetitive and some of them will be non-repetitive. For those who are not repetitive here, for those we can figure out c by this formula. If m equals to mi is not repetitive, then c can be figured out using this formula. C equals to minus of phi n minus m by phi n dash m, and here we will put the value m as mi. Therefore, we have mi and also we have figured out ci. That means we can now write down the formula for asymptotes. Then y equals to mix plus ci are the asymptotes. That's what we were looking for. We have covered the asymptotes. Now the one question, using this formula, if you have a curve, given curve f of xy like this, using this working rule you can get m and c. Using m and c you can write down the asymptotes. Okay, so you are done. Now the one problem comes. I have written here, if mi is not repetitive, then only you can use this here. If some of the mi are repetitive, then you can get minimum number of c. For that mi you need another one formula, because this formula will not work then. So what is the other formula when mi are repetitive? Okay, let me use this portion. If mi is repetitive, then obtain, what are the things I have to obtain? Phi n double prime m, phi n minus 1 prime m, phi n minus 2 m. Okay, After getting this, next when if mi if mi is repetitive, then phi and dash m equals to 0. Therefore, to get C, we use a different formula. We use the following formula. Which one? The following formula is C square by 2 phi n double dash m plus C into phi n minus 1 dash m plus phi n minus 2 m is equals to 0. With this formula, we can get the value of C. Since we have given the values of C, then there is nothing else to calculate because we already have M and now we get C. And look, this is a equation, this is a quadratic equation of C. Therefore, this gives two values of C. If we get two values of C, then we get two asymptotes, right? So these are the working rules. So do you recognize what is happening over here? The working rules are little bit messy, but it is straightforward. When you do a problem, then it will be very convenient and easy to you to handle this. Just let me give you the rough idea what I did, and let me tell you again. First, you will be given a curve like this, f of xy equals to 0. So think of this. After that, you are going to find asymptotes which are not parallel to coordinate axis. So they will be looks like y equals to mx plus c. These working rules are giving you a trick to figure out m first, and then for each m find out c. When you are done with m and c, then put them and make the asymptotes which was desired. Okay. And the first option was find phi n m. Phi n m is which one? In the curve, the nth degree terms. Find the nth degree terms. Here, the nth means 3. Highest degree is 3. The third degree terms are these two. And I have written them phi 3m. Second option was, after that put x equals to 1, y equals to m in that portion. I have put it. And go on. You study, you read this, you will understand. Okay, so this formula is written down, and now I will apply this working rule. We have these two problems. We will solve applying that working rule one by one. First we will solve the second one, then for the first one. Okay. For this, what we have to do, before applying the working rule, you must know that we already covered the vertical and horizontal asymptotes. You first have to look for that one. So first, how many asymptotes we can get from this curve? The answer is, the degree is 3, so it has 3 asymptotes. 3 asymptotes. Okay, so look for the vertical one first. Vertical asymptotes. For that, coefficient of y square, y. What is the highest coefficient of y? Y square here equals to 0. This gives x minus 1 equals to 0. And for the horizontal asymptotes, coefficient of x cube is constant, therefore there is no horizontal asymptotes. No horizontal asymptotes. Now, put x equals to y equals to m in the nth degree. Here it is n equals to in the nth degree n equals to here 3, 2, in the nth degree terms we get, what we get, phi 3 m. Phi 3m equals to, in x equals to 1 m square minus 1. Okay. Phi 2m is equals to minus m square. Now we calculate phi 3 dash m. This gives 2m. Okay. For m, we will solve for m. We solve. Now, phi 3m equals to 0. This gives m square minus 1 equals to 0. Implies m equals to plus 1 minus 1. See, there is no repetition in m. Plus 1 and minus 1. Since there is no repetition, therefore we can use the formula of C for the first formula of C. Okay. For m equals to 1, C will be minus phi 2 1 phi 3 dash 1. This will give you minus phi 2 1. Phi 2 1 is minus 1. Phi 3 dash 1. Phi 3 dash 1 gives 2. So this becomes plus half. For m equals to minus 1, C is equals to minus of, like this, phi 2 minus 1 by phi 3 dash minus 1. This gives minus phi 2 minus 1. What is phi 2? Phi 2 is here, minus 1. This gives minus 1. Phi 3 dash minus 1. Phi 3 dash minus 1, minus 2. So we get minus of. Therefore, what will be the asymptotes? We have calculated M and C. So the asymptotes are y is equals to, for this, x plus half, and for this one y is equals to minus x minus half. Are the asymptotes. Okay, so these are two asymptotes, and the first one that we have calculated from the vertical asymptotes one. Therefore, we get the three asymptotes, as it seems that this curve has 3 degrees, so it should have 3 asymptotes, and we have figured out all the 3 asymptotes. Alright, now we move to the next questions. These questions or these problems I have written down because I will use in this problem the formula of C that I have written down in the later portion. That means we will have a repetition of M for this problem. Then how will we do? Okay, like before, first you have to find vertical one and then you have to find the horizontal one. And number of asymptotes is x cubed, so 3. Vertical one, is there any vertical asymptotes? Vertical? And horizontal? For vertical one, coefficient of highest power x, y, coefficient of y, so yes, this y square. Vertical would be coefficient of y square equals to 0. This gives x equals to 0. So this is a vertical asymptote. And horizontal one, x cube has coefficient constant, so therefore no horizontal asymptotes. Next, put x equals to 1, y equals to m in the nth degree, n equals to 3 to terms. We get 5 3 m. 5 3 m equals to 1 minus 2 m plus m square. Okay, this is our 5 3 m. We took the derivative 5 3 dash m later. First we write down phi to m. Phi to m is this portion, x square minus xy. This phi 3 dash m is equals to minus 2 plus 2m. Okay. Now we will solve this to get m. Now phi 3 dash m is equals to 0. This gives 1 minus 2m plus m squared is equals to 0. That is m minus 1 squared plus 0. This gives m equals to 1 1 2 1. Look, since m is repeated here 1 and 1, we do not need to calculate C from the first equation, we can directly move to the second formula for getting C. Okay, so what was our second formula for getting C? For that second formula, we need phi 3 double dash m. Phi 3 double dash m is 2. Phi 3 double dash m is 2, and phi 2 dash m. Phi 2 dash m is equals to minus 1, and phi 3 m. What is phi 3 m? Phi 3 m is the x term. There is no x term. See, this is a 2 term, so this would be 0. Now we will use the formula. For getting C, we have to use this formula. To get C, we use C square by 2 phi 3 double dash m plus C into phi 2 dash m plus phi 1 m is equals to 0. Oh, of course, it's phi 1. A mistake. Okay. Now, this gives C square by 2 into phi 3 double dash m. What is m here? This is 2. For m equals to 1. As there is nothing. Look, this gives phi 3 double dash 1 also equals to 2. Phi 3 dash minus 1 0. And now put this value here. 2 plus C into minus 1 plus 0 is equal to 0. This gives C plus minus C. Okay. C square minus C equals to 0. This gives C equals to 0. C equals to 1. And m for this C, m is 1. What will be our asymptotes then? We can write for m equals to 1. Therefore, the asymptotes are, the asymptotes are y is equals to m equals to 1, x plus c. C is 0 and another one is y equals to x plus 1. We have two asymptotes here and one vertical asymptote. That means all total we have 3 asymptotes. We verified that there are 3 asymptotes for these curves. So in this way we can solve the working rule that I have written down, and I applied that working rule in this way. This is straightforward. You can just do it. You have to just figure out that what is happening over here. You have to look aside and be careful while calculating the things. Otherwise, it's so straightforward and very easy. Okay. You have a lot of exercises in your book, you can solve. I am not giving any homework and other things.